Hey folks, this is JBrains. Welcome to the world's best introduction to test-driven development, level 1. Now before we get started, there's a lot in this course, and it's not necessarily clear exactly how you should use it. So I want to take just a few moments to talk about what is test-driven development and the ways in which it is different things to different people at different times. And that stuff is going to be important to you as you progress through this course. Now I know what you're thinking. This is just boring time filler stuff, and I promise it isn't. 4 stages of TDD is a learning model that I have observed both in my own practice and with people who've gone through this course over the last nearly 20 years. And the idea here is to illustrate or to describe to you some of the ways that you can get more out of this course by not trying to drink from the entire fire hose at once. Don't try to learn everything at once. Depending on what your experience is, you might need to focus on different things as you progress through, and that could change over time. So the idea of 4 stages of TDD is to give you a way of understanding sort of a progression of learning that people typically go through. And if it applies to you, then, well, like most people, it will apply to you. Then you'll be able to more easily understand or feel better about focusing on what's important to you now and learning the rest later. So the first stage is usually when people are drowning in bugs. So this is what causes a lot of people to become interested in test-driven development in the first place. They hear some rumblings that it's going to help them with bugs. Bugs is a huge problem for them right now. You could even say it's their bottleneck, to use the theory of constraints term. And so in this stage, I encourage programmers to focus on test-first programming. Test-first programming is both the original name of test-driven development, but I have sort of repurposed it to mean a kind of weaker form of test-driven development. I don't mean weaker like worse. I mean weaker like fewer rules. In fact, there's only one rule for test-first programming, which is you have to write the test first. You can do anything, you can do everything else the way you normally do it, but when it comes time to sit down and write the code, always start with a failing test. So the only rule you have to follow is always start with a failing test. You can do everything else the same way you normally do it. And the objective here is to focus on reducing the cost of defects by controlling one key aspect of the cost of defects. And that's simply how long it takes you to notice them. If you notice your mistakes 10 seconds after you make them, those mistakes are a lot easier to fix than they are if you notice them a week later, or a month later, or a year later. And so when we do test-first programming, by starting with the failing test, we essentially drive down the time between when you make a mistake and when you notice it to almost 0. And when we do that, we reduce the cost of fixing those mistakes to as close to 0 as we can make it. Not to 0, but as low as we could possibly make it. And that's all you have to do. If you're in stage 1 and you are drowning in bugs, then just focus on test-first programming and don't worry about anything else. You don't have to change anything else about the way you practice. But what will happen over time is your bug rates will go down. That's what I experienced. And when your bug rates go down, suddenly you'll notice that you have spare capacity in your mind to think about other things. You'll start to notice other things that are not quite right about what happens when you write the tests first. And that means that you're ready to progress to another stage. And in stage 2, this is where you're doing test-driven development for the first time, because your bottleneck is no longer bugs, but indeed the design. This is where you start to notice that if you just try to write tests naively, that there are certain parts of the system that are easier to test than others. And what does that really mean? And so the technique that we had is called refactoring. This is where you are changing the structure of the system without changing the observable behavior that you care about. And that's important, that you care about. Changing the structure of the system will always change some aspect of the observable behavior. But if it doesn't change the parts of the behavior that you need to worry about right now, then for you, that's refactoring. And the goal in refactoring is essentially to gradually change the design to make it easier to take the next step. Is to avoid the situation where you feel like you need to throw away large sections of the code and write them again because now you know how they should have been designed. And as you build your refactoring skill, the design no longer becomes the bottleneck in a very specific way. You no longer feel imprisoned by past design decisions. A decision that was made last week or last month or last year, that maybe it was a good idea at the time, maybe it was never a good idea. It doesn't matter. As you build your skill in refactoring, you find it easier to just gradually change the structure of the code so that you could almost pretend like that design decision was never made, which feels very different than, say, noticing that the design is terrible, finally understanding the way the design should be, and then taking out a fresh piece of paper and starting again from scratch. The idea in test-driven development is this is when you start actually letting the feedback that you get from trying to test the system drive your design decisions. And then eventually you reach the point where refactoring is really not that hard, but sometimes it's a bit tedious. Sometimes, in order to make the next feature easier to add, you need to put in a couple of hours of refactoring. Sometimes it's 10 minutes, sometimes it's 2 weeks. And this volatility starts to become a problem because we've probably all had that experience of being in a meeting on Friday afternoon and saying, yeah, I understand that feature, no problem, it'll take a week. And then on Monday, with coffee, when you sit down to actually write the code, you open up the code base, you see how terrible that part of the design is, and you realize that it's going to take a month. And that volatility eventually becomes a bottleneck, where we can't really predict how much refactoring we're going to need to do in order to make the next feature easier to add. And one of the ways that we solve this problem, well, there are two of them. One of them is tiny steps, and the other is relentless simplicity, the so-called Yagni approach. You aren't going to need it. By working in tinier steps, we smooth out the cost of refactoring. We refactor more often, in smaller steps, more safely, more accurately, and it's spread out over a longer period of the project, so it doesn't feel like we're rushing to get things done, then stopping to refactor everything, then rushing to get things done, then stopping to refactor everything. But instead, we're just cleaning the kitchen while we cook. And the advantage to these tiny steps is that it allows us to really keep things simple. If I trust myself to refactor tomorrow, then I don't have to do so much over-engineering today. I can build just enough to solve the problem today, knowing that when I need to generalize the direction a little bit, when I get there tomorrow, I will actually do it. And I'll do it by refactoring in tiny steps. So not only does this help me reduce volatility in how much refactoring I need to do, but there's a much bigger effect. And that is that if I trust myself to refactor tomorrow, then I don't have to over-engineer today, which allows me to release features sooner. I can keep the design relentlessly simple, release the feature now, get it into the hands of customers, and then refactor while they're figuring out how to make money with my code. And because we actually trust ourselves to do that refactoring when we get there, we don't have to worry about over-refactoring now. And if you do that long enough, then you get to the point where you can't perfectly forecast how much refactoring you're going to do, but the amount of refactoring that you do to make the next feature easier to add becomes easier to predict over time. Volatility decreases and you become more reliable in forecasting costs, because let's face it, no matter how much we want to stop forecasting costs in a project, they're probably going to ask us to do it. And eventually you reach the point where, well, actually, I don't really know. I get the sense that the bottleneck in stage 4 is the changing context. Although I can't be sure, because I think I'm in stage 4. And if I'm in stage 4, I don't necessarily know what makes stage 4 stage 4. Maybe there's a stage 5 and I just haven't been able to see it yet. Maybe one day. But what I do know is that even after I am comfortable with driving the cost of bugs down to 0, comfortable refactoring, and even comfortable working in teeny tiny steps, what starts to change is the context. I do test-driven development differently in Ruby than I do in Java than I do in Haskell, because the tools are different. The kinds of tests that the platform runs for me are different. And in fact, the way that I work in greenfield systems and in legacy code systems changes. The kinds of trade-offs that I made, when do I write tests, how much testing do I actually do? How much testing do I do in pre-production compared to doing monitoring of the real-time system in production? All these issues of the context start to become my bottleneck, that what I need to figure out isn't how to do the right thing, but what is the right thing in different contexts. And a lot of people try to rush to stage 4 before they've even mastered the basics in stages 1, 2, and 3. And so in stage 4, I adapt the way I practice test-driven development in order to match the context as best I can. And when I'm confused, I ask my mentors for help. This allows me to do things like, when I'm in legacy code, I know that there are certain refactorings that I can do safely, especially in Java because IDEA does them for me. So maybe I don't need as many tests up front. Maybe I can do 3 or 4 or 5 key refactorings to decouple parts of the system so that I can focus on adding tests here instead of being forced to add tests for the entire system at once. And when I reach the point where I trust myself to do this, then, well, it's easier to add tests, which means that when I really do need those tests, I'll trust myself to add them, which means I don't have to panic. I don't have to stop the presses and add tests for 3 weeks and have managers and customers and architects screaming at me wondering when I'm actually going to get real work done. Well, I am doing real work. But they can't see it. As I build up skill in changing how I practice test-driven development in various contexts, I become more reliable. People can rely on me to produce good results steadily over time. And sometimes that means that I don't add as many tests here because I'm going to add them later. Or I need to break things apart so that I can spend 3 days adding tests instead of 3 weeks trying to add tests for the entire system at once. And as I build that skill, I trust my own judgment better. In fact, maybe rather than calling stage 4 virtuosity, maybe we should call it wisdom. Because that's really what starts to emerge in stage 4, is my ability to adapt to a changing context is an expression of the wisdom that came from all the good judgment I've built through the years in practicing from stage 1 through stage 3. So, which stage seems to describe your situation the most? I mean, you can't answer me now, but think about it. Where am I? Am I drowning in bugs? Am I struggling to refactor accurately and safely? Am I struggling with sometimes I need 2 weeks of refactoring and sometimes I only need 2 hours? Or am I struggling with trying to understand what's the right way to practice test-driven development in PHP compared to in Elm? Whatever stage you're in helps you decide what to focus on in this course. Many of you are in stage 1 and stage 2. Some of you might be in stage 3. And if you're in stage 4, maybe you should be teaching this course. But the way that I want you to use this model in this course, and especially the way that we'll use it in the online community edition of this course, is that you'll choose how to practice based on which stage you think you're in. And so if you're in stage 1, you might not focus too much on refactoring. I mean, you might try to remove duplication. Maybe you'll try to improve names, but your focus will be on building the habit of writing the tests first so that you can drive down the cost of defects. But if you're in stage 3, if the idea of refactoring itself is kind of boring, but you want to see more interesting examples of how to refactor and practice that more, then maybe you need to focus on refactoring in the tiniest possible steps and writing the smallest test that could possibly fail and writing the least code that could possibly pass. That those tiny steps are the things that you're going to focus on. People in stage 1 and people in stage 3 are going to do these exercises differently. And that's why this model is important to me. That's why I'm starting here. Now, I can't tell you which stage you're in. And even if I could, you shouldn't believe me. That's for you to decide. And if you're not sure, it's totally okay to say, I think I might be in stage 1, even though I might possibly be in stage 2 on my best days. That's fine. All that matters is that you use this as a way to help you decide what are you going to practice. And when you're not sure what the right decision is, don't panic. Just follow your energy. Do what you have energy to do. And if that means refactoring less and writing more tests and waiting for the duplication to accumulate until you just can't take it anymore, that's perfectly fine. So here are some basic practice strategies depending on what stage you're in. In stage 1, you're building the habit of writing the tests first. That's all you're trying to do. You're going to have the impulse to rush in and write production code. Pause. Write a test list, write the test first. And in stage 2, you're going to build the habit of refactoring every time a new test passes instead of making a bunch of code work and then refactoring it until it doesn't suck anymore. Now, what you're trying to do is to build the habit of refactoring a little bit as you go. We call it cleaning the kitchen as you go. And in stage 3, you're building the habit of tiny steps, such as writing the smallest test that could possibly fail, writing the least code that could possibly pass, and doing all the hard design work in the refactoring step, and making those refactoring steps as small as possible. Instead of throwing this function away and rebuilding it the way you want it, How can I refactor to get there in 5 little steps while keeping all the tests passing? And if you're in stage 4, then you should build your own version of this course. I don't mean compete with me. Don't do that. But maybe you want to build a version of this course that focuses on what your coworkers are concerned about. When I'm building a course for a mass audience, I can't focus in on the context of, say, highly distributed real-time systems or medical devices or financial technology. They all have different trade-offs. I can't possibly build that all into a general purpose introductory course, but you can. So if you think you're in stage 4 or are soon to be in stage 4, then maybe you can take the ideas in this course and produce a customized version that fits better the specific context of the people that you work with. And they might appreciate it, but you should probably ask them to go through my course first. This is not a maturity model. I do not do maturity models. I'm not trying to classify you as stage 2, as stage 3, and stage 4. That's for you to decide. It's for you to decide, what am I going to focus on? What am I going to practice? How shall I practice? And by the way, this is not a linear progression. Not everyone goes through all 4 stages, and they certainly don't go through all 4 stages in order. It's chaotic at best. On your best days, you're in stage 3, and on your worst days, you're stuck in stage 1. Not even stuck. You're just there. If all of a sudden you inherit some crappy code, then you're drowning in bugs again, and maybe you're back in stage 1. So act like it. Don't focus too much on tiny steps when you're just trying to get out from under this mountain of defects that you've inherited. And by understanding these stages, you can reduce conflict in how you work with others. If somebody else on the team wants to focus on design, but you need to focus on writing the tests first, then being able to say, hey, dude, I'm in stage 1, leave me alone, could help resolve the conflict quickly. And by the way, out there in the horrible outside world, you're going to find articles with titles like "Test-Driven Development is about design, not about testing, you idiot." Okay, congratulations to the author for learning something new. Just because you made it to stage 2 doesn't mean that all those poor unwashed masses of people in stage 1 are idiots. It just means that you're ahead of them in the textbook. Big deal. By understanding the stage you're in, you can adjust how you practice, and you can use your practice in a way that's going to help you learn, and eventually you'll progress through to the next stage. And it doesn't matter when that happens. It's fine. TDD is not a video game with levels to conquer and big bosses to beat. TDD is a way of learning and understanding deeply the principles of good design. That's what we're here to do. And so it doesn't matter to me whether you're in stage 1, stage 2, stage 3, or stage 4. What matters to me is that you use that information, your best guess about what's important to you, to focus your energy on practicing what's important while trying to maybe reach for just enough of a challenge to build that healthy muscle. So we're going to start with stage 1. Series 1 and 2 of this course are focused on stage 1, developing the habit of writing the test first. As we move into series 3 through 5, we're going to do mostly stage 2 with a bit of stage 3. I'm going to take small steps. Sometimes those small steps are a bit uncomfortable. Don't worry about it. You don't have to follow my tiny steps. I just want to show you what it looks like. Most of this course is focused on concerns of stage 2. How do we refactor safely and accurately, and how do we use feedback from the tests to drive our design decisions? And so if you look at some of the tiny steps that I make and they make you laugh or they make you surprised, that's fine. Don't worry about it. Do whatever you need to do. Start by building the habit of writing the test first, then start refactoring, and then worry about taking steps as small as I do, maybe even smaller. At the beginning of the course, some of the exercises will be simpler and more elementary. If you're in stage 3 and are doing the elementary exercises over again, then focus on tiny steps. Later exercises, by necessity, will include options for various stages, so especially in the online community edition. We'll make a distinction that, in stage 2, you should practice this way, in stage 1, you should practice this way. And if something feels too complicated, if an exercise feels like it's beyond your grasp, don't panic. Just go back to stage 1 or stage 2, wherever you feel like you are, and practice on focus on the thing that's going to help you. Don't worry about it. If you're not getting something, you just might not need it yet. It's hard to focus on tiny steps when you're drowning in bugs. And when you're no longer drowning in bugs, all of a sudden, overnight, those tiny steps become more interesting. When you're ready, those concepts will still be there. And if you'd like to read more about this at a larger scale, although here I've been talking about how we learn test-driven development inside the practice, there's also the question of how test-driven development fits into the larger software development lifecycle. And so an article that you can find, How Test-Driven Development Works and More, shows you how we can make the progression from test-first programming to test-driven development to behavior-driven development to ever bigger practices that essentially end up with the kinds of things that we think of as lean startup and even beyond budgeting. That you can progress through various practices at your own pace, and that you don't have to jump in and do all the lightweight software practices at once, but that you can start from where you are and gradually progress through the stages, and then before you know it, you're a fully certified lightweight. Well, I'm never going to do certifications in lightweight, so ignore that I said that. Enjoy the course. Thanks very much for your time and attention, and let's now set up some environments and start writing some tests.